This is the MCAT Intensive Review, brought to you by In Time TV. I'm Dr. Ogan Gurel. We're in the Physical Sciences section, the Chemistry subsection. The chapter is Equilibrium and Kinetics. The topic is Reaction Energy Profiles. A PDF will pop up during the break, which you can print out, annotate, review, and study as you see fit at your leisure during the course of the lecture or afterwards.
Advanced electrocardiogram technology from GE. Small enough to fit in the backpack.
Very good.
Powerful enough to bring modern healthcare to places like rural India.
Reaction energy profiles. Reaction energy profiles are a very powerful way of understanding in one glance, visually, the kinetics and thermodynamics of a reaction. Sometimes the reaction energy profiles are not exact, and sometimes they do reflect actual precise energy determinations or measurements. But in any case, they are very useful in understanding, as I mentioned, the reaction kinetics and thermodynamics. So let's look at one of these. There are two major components to a reaction energy profile, which is this curved line here. One is what's called the reaction coordinate. It's not a formal horizontal axis like time or distance, but it represents the progress of a reaction. The vertical axis is the free energy, G, of the reaction, and is a reflection of the energetics of the reaction, and free energy, of course, being related to the second law of thermodynamics, the energetics, the enthalpy, and the entropy. Obviously, the definition of free energy, etc., is the topic of another video clip. But in essence, you start at a reactant, which is at a certain free energy, and you end with a product, which is at another free energy. And there are two parameters, the kinetics and the thermodynamics. The thermodynamics is the difference of energy between the product and the reactant, and that is the delta G naught here. That defines the thermodynamics. If you have a reaction energy profile in which the product is at lower free energy than the reactants, namely a negative delta G naught, final minus initial is negative, that is an exergonic or favorable spontaneous thermodynamic reaction. If the delta G is positive, that's because the product is at a higher delta G or higher free energy, and the delta G is positive, that would be endergonic or unfavorable or non-spontaneous reaction. On the other hand, we have the kinetics of a reaction. The kinetics is not the delta G naught, but the delta G transition state. And we're talking about not the energy transitions between the reactant and the product, but the energy transitions between the reactant and the transition states. So, for example, this delta G1 transition is the reactant in transition to transition state 1. A very high transition state or high reaction barrier, activation barrier, corresponds to a slow reaction. A very small activation barrier or small delta G transition is a fast reaction. Reaction energy profiles can also demonstrate intermediates, and in this case this is an intermediate here, and hence we have two transition states as described. So this reaction energy profile can depict both the thermodynamics in this case an exergonic or spontaneous reaction, and kinetics of a reaction. In this case, it's a pretty large delta G transition state, conceptually speaking, and hence a relatively slow reaction. So one of the interesting things is that if this reaction energy profile reflects a two-step reaction, we can see in our notes that the delta G1 of transition is greater than delta G2 of transition. That means that path of the transition is slower, has a longer time than the second path, and path of the transition state 1 is the slow step in this two-step reaction, or the rate determining step. The other thing very important to consider is that this diagram also shows you that the thermodynamics is not the same as the kinetics. In fact, it's completely unrelated to the kinetics. The thermodynamics of a reaction is defined by the delta G naught, the difference in energy between the reactants and the products. Whereas the kinetics, the speed of the reaction, is determined by the delta G transition state, which is the energy difference between the reactants and the transition states corresponding to that reaction. This concludes the video clip on reaction energy profiles.